Hi everyone, good morning. What's up? All good? Great. So today we will be solving the question, make the string great. So let's see what is this question. Given a string S of lower and uppercase English letters, a good string is a string which doesn't have two adjacent characters such that SI is a lowercase letter and SI plus 1 is the same letter but in uppercase or vice versa. So we are given with that string is good if it doesn't have two adjacent characters in the way that one of them is uppercase and one of them is lowercase. Okay. To make the string good, you can choose two adjacent characters and make the string bad and remove them. Okay. So you need to make the string good. And what you can do to make this string good? You can just choose two adjacent characters which makes the string bad and remove them. Okay. You can keep doing this until the string becomes good. Okay. Return the string after making it good. The answer is guaranteed to be unique under the given constraints. Notice that an empty string is also a good string. Okay, so we have been given with a bad string and we need to convert it in a good string. And how we can convert it in a good string? By removing two adjacent characters when one of them is uppercase and one of them is lowercase. Okay, and if all the characters are also removed from this string, then it means it becomes an empty string. Then it will be considered as a good string. Okay. So let's see with these examples. So see, if you can see here is that these two characters are making the string bad. So if we remove these two characters, then our string becomes a good string, right? So now the question comes here is that how will we compare these two uppercase and lowercase characters? So the SI value of capital A is 65 and small a is 97, right? So their difference is 32. Okay, so we will be comparing the small uppercase and lowercase characters with the help of their SI values, right? Because there is no other way to compare the uppercase and lower case characters. Okay, so we will be using SI values. So how we can now remove these characters from this string? So let's say if we use a stack and start traversing this string. So first of all, we encountered L, right? If stack is empty, we will simply push L in our stack. Now we are at E. Now we will compare. If the absolute value of the coming element and the top element of the stack is equals to 32? No. So we will simply push that element in the stack. Now we are at capital E. Now we will again compare. Is the absolute difference between the coming element and the top element of the stack is 32? Yes, it's 32. So we will simply pop that element from the stack and we will not push the incoming element. Now we will again come at the next element. Again check whether the absolute value between the coming element and the top element is 32. No. So we will simply push that. Now keep on checking this condition and then in this way we will simply iterate our whole string. Okay. Like now what we need to do? We need to pop out these elements from the stack. So if we pop out these elements from the stack, they will be popped out in the reverse order, right? So then we will simply reverse this popped out string and we got our answer, right? So let's see another example as well. So let's say in this example also we have a stack. Okay, now we start iterating this string. Okay, so if our stack is empty, then we will simply push this string in our stack. Okay, push this character in our stack. Now we are at the second character. Now we will again compare whether the absolute difference between the coming character and the top element of the stack is 32 or not. If not, then we will simply push that element. Now we are at this element, this character. Now we will again check whether the absolute difference is 32. Yeah, it's 32. So we will simply pop this element and don't push this element. Okay. Now we are at this character. Now we again check whether the absolute difference is 32. Yeah, it's 32. Now we will pop this element and don't push this element. Now we are at this. See, as the stack is empty, so we will simply push that element in our stack. And then we are at this element. Now we will again check whether the absolute difference is 32. Yeah, it's 32. So we will simply pop this character and don't push this character. So we have got our result as an empty string. Right? Okay, so let's see how we can code this approach. So see here, I've created a stack and then stored the length of the string, and then iterating the string and then checking if stack is empty, then push that character in our stack, right? Otherwise, check for the absolute difference. If it is 32, then pop that element from the stack. Otherwise, push that element. Simple. And at the end, simply iterate the pop out the all the elements from the stack and then reverse all the elements. And then finally we have got our good string. Simple. Okay. So let's see the time and space complexity for this. So as you can see here, we are doing one iteration for iterating the whole string and then I and then iterating the stack and then reversing the result. So it can be big of n plus n plus n. So it will be overall big of n. Okay. And the space complexity will be big of n because we are using stack here. Okay. And in the worst case, we can end up storing all the characters of the string in our stack because it might be a good string from the starting as well. So this will be the time and space complexity for this object. Okay. So we cannot reduce its time complexity because we need to check for the complete string. This is for sure. Right? So can we reduce this space complexity? Yeah, we can reduce it. Do we really need this stack thing? Think about it and then come back to the later part. Okay. So let's see, we have this string, right? So do we really need that stack part? No, because let's say if we have just this result string, okay. So now start iterating this string. Logic will remain same, everything will remain same. We are just using this string instead of stack. Okay. So let's say if stack were empty, then what we were doing? We were simply pushing that element in our stack. Same logic here. If string is empty, then what we will do? We will just simply push this element in our string. Move on to the next element. Now, if the string is not stack was not empty, then what we were doing? We were just checking for the absolute difference. Same logic here. Now string is not empty, we will check whether the absolute difference between the coming element and the last element of the string is 32. Now, then we will simply push this element in our string. Now we are at this. Again check whether the absolute difference between the coming element and the last element of the string is 32. Yes. So we will pop out this element from the string. Now we are at this. Again check for the absolute difference. Yes, it's 32. Then we will remove this character from string. Now we are at this. Now string is empty. So we will simply push this character. Now we are at this character. Again check for the difference. Yeah, it's 32. So we will simply pop out this element from the string and don't push this element. So we have got our answer as an empty string. So here you can see that we have solved this question without using the stack as well. Okay, so let's see how we can code this approach. So here I have stored the length of this string in a variable n and then string result created and then checking. If the size of the result is 0, then simply push that character in our string. Otherwise, check for the absolute difference. If it is 32, then remove that element from this string. Otherwise, push the coming element to this string. And then at the end, we just need to return the result. Simple. So what will be the time complexity? Its time complexity will be big of n as we are doing just one iteration. And the space complexity will be big of 1 as we have reduced that extra stack space. Okay, cool. So you can see that time complexity is also reduced to some extent. We cannot see in terms of this, but yeah, see, because here it is requiring big of three n. One loop for this, one loop for this, and then another for this, right? And here we are just requiring this one loop. So it's become big of n. So we have reduced time complexity also to some extent, but not that much. So yeah, mainly we have reduced the space complexity from big of n to big of 1. Okay, so this was all for this question. This was a kind of easy question. I hope you get it. If you still have any doubts, you can surely post in the comment section. I will try to answer them. Okay then, bye bye guys. See you soon in the next video.